Dear students, I'm Dr. Nuzhat Gul and today we'll be studying reflection. So, when a ray of light, when we talk about a ray of light, we basically mean the direction of propagation of light. The ray of light represents the direction of propagation of light. It carries the light energy and follows a straight path. What happens when light ray strikes something? When light encounters an obstacle or interacts with an interface of a different medium, it may be reflected, that is bounced back, absorbed, or transmitted. That is, it will pass through the obstacle. Meaning thereby, if we have got a ray of light like this and it strikes an obstacle, what happens? It may be bounced back, right? Reflected. It may be transmitted. Transmission means it will pass through this obstacle, or some part of it will be absorbed. Reflected, absorbed, and transmitted. Now, when a ray of light approaches the surface and light bounces back, it has approached the surface and light has bounced back. It is called the reflection of light. The ray of light that strikes surface is called the incident ray, and the ray that bounces back is known as reflected ray. So this ray of light strikes the obstacle. ये इंटरफेस के साथ स्ट्राइक की है. We call this ray as incident ray. And the ray that bounces back, ये bounce back हो रही है. It is straight. So I'm not able to draw it straight for that. I'm sorry, but these are straight lines. It travels in a straight path. तो ये हमारी reflected ray होती है. An object is visible only whenever eye receives light from that object or the object reflects the light. हमें कब चीजें दिखाई देती हैं? जैसे हम इसी की बात करें, इस चीज पे लाइट रे स्ट्राइक करती है, किसी भी ऑब्जेक्ट पे लाइट रे स्ट्राइक करती हैं और वो लाइट रेज रिफ्लेक्ट होकर के दे आर रिसीव्ड बाय आवर आई, राइट? ये इस पे स्ट्राइक की, ये रिफ्लेक्ट की, एंड दीज आर रिसीव्ड बाय आवर आई, एंड व्हेन एवर आई रिसीव्स दीज, जब हमारी आई ये रिसीव करती है, द ऑब्जेक्ट बिकम्स विजिबल. This is the reason why we are not able to see in the darkness. Darkness में हमारी आंखों में तो बराबर रोशनी होती है, but still we are not able to see an object. Reason? उस ऑब्जेक्ट पे उस टाइम कोई लाइट जो है स्ट्राइक नहीं करती है, जिसके नतीजे में the reflected light does not reach our eye और हम देख नहीं पाते हैं. So the moment we light a bulb, उसकी लाइट इस ऑब्जेक्ट पे पड़ती है, रिफ्लेक्ट होकर के हमारी आंखों में पहुंच जाती है, एंड द थिंग्स बिकम विजिबल. सो an object is visible only whenever eye receives light from that object or the object reflects the light. Objects that are not source of light become visible as they reflect the light incident on them by the source. यानी कि source of light वो चीज होती है जो खुद light emit करती है. This object does not emit its own light. तो ये कैसे विजिबल हो जाती है? ये विजिबल बन जाती है जब इस पे लाइट पड़ती है, रिफ्लेक्ट होकर के हमारी आंखों में पहुंच जाती है. जबकि सोर्स ऑफ द लाइट से हमें डायरेक्ट लाइट मिल जाती है, उसी वो खुद ही इमिट करता है लाइट. ठीक है, जैसे हमारे पास एक बल्ब है, वो खुद ही लाइट इमिट होकर के हमारी आंखों में पहुंच जाती है, एंड इट मेक्स द ऑब्जेक्ट विजिबल. नाउ सो वी सेड कि जब लाइट स्ट्राइक करती है एक सरफेस को, एक ऑब्जेक्ट को, और ये बाउंस बैक होती है, तो हमने कहा कि हम इसको रिफ्लेक्शन कहते हैं. लाइट के बाउंस बैक होने के, इंसिडेंट लाइट के बाउंस बैक होने को हम रिफ्लेक्शन कहते हैं. सो व्हाट आर द टाइप्स ऑफ दिस रिफ्लेक्शन? रिफ्लेक्शन की क्या क्या टाइप्स हैं? पहले हमारे पास है, वी हैव गॉट रेगुलर रिफ्लेक्शन, इट्स आल्सो नोन एज स्पेक्युलर रिफ्लेक्शन. We have got diffuse reflection, irregular रिफ्लेक्शन भी कहते हैं इसको, and we have got multiple reflection. Let us first discuss this regular reflection or specular reflection. तो बेसिकली जो रेगुलर रिफ्लेक्शन है, एज द नेम इंडिकेट्स, इसमें क्या होता है, आई विल जस्ट ट्राई टू एक्सप्लेन इट. ये मान लीजिए हमारे पास एक यूनिफॉर्म सरफेस है, इसके जो पार्टिकल्स है यूनिफॉर्मली अरेंज्ड है, ठीक है ना. जब इस पे एक वेव फ्रंट ये करता है, आई मीन इंसिडेंट होता है, तो वो जो रिफ्लेक्टेड वेव फ्रंट होता है ये एग्जैक्टली सेम डायरेक्शन, मतलब लाइक इट इज इन द सेम डायरेक्शन, ये जिग हैफजर नहीं होता है. यानी कि जो आपके ऑब्जेक्ट के वेव फ्रंट जो है इससे आता है, उसी तरह का करेक्टरिस्टिक वेव फ्रंट आपको रिफ्लेक्टेड इसमें मिलता है, रिफ्लेक्टेड बीम में मिलता है. उससे क्या हो जाता है, all the information about the object is preserved, क्योंकि आपको बिल्कुल वैसा ही वेव फ्रंट मिला जैसा इंसिडेंट था, in the same like in one single direction. तो what do you get, आपके पास यहाँ पे एक मिरर है, ठीक है, एक सरफेस है, ऑप्टिकली प्लेन मिरर है, तो आपको इस चीज की इमेज बन जाती है. दिस इज व्हाट यू कॉल एज स्पेक्युलर रिफ्लेक्शन. सो this specular reflection occurs on optically plane surface coated with a uniform layer. Uniform layer बिल्कुल एकदम uniform layer होना चाहिए हमारा, यानी कि जो इसके particles हैं एकदम बिल्कुल straight, no zigzag, nothing like that, एकदम straight, बिल्कुल smooth है. इसकी आप surface देख लीजिए, it should be बिल्कुल smooth होनी चाहिए हमारी इसकी surface, ठीक है, right? No bumps, nothing doing, right? तो नेक्स्ट इससे क्या हो जाएगा, वी विल गेट अ शार्प रिफ्लेक्शन लाइक द वन वी गेट इन अ मिरर. जैसा मैंने आपको कहा, हमें एक शार्प रिफ्लेक्शन मिल जाएगी. द इंसिडेंट रे इज रिफ्लेक्टेड इनटू अ सिंगल आउटगोइंग डायरेक्शन. यस, सिंगल आउटगोइंग डायरेक्शन. तो इसके सिग्नेचर वेव फ्रंट को ये प्रिजर्व करता है. इट प्रिजर्व्स all the information regarding the object and we get a perfect image of the object. ये देख लीजिए, यहाँ से इंसिडेंट वेव फ्रंट आ रहा है, ठीक है, ये हमारा मिरर है, ऑप्टिकली प्लेन सरफेस है जो कि बिल्कुल यूनिफॉर्मली सेट इसके मॉलिक्यूल्स है. हमारा जो रिफ्लेक्टेड वेव फ्रंट है ये एकदम एक ही डायरेक्शन में सारा है. इट प्रिजर्व्स ऑल द इंफॉर्मेशन ऑफ दिस ऑब्जेक्ट एंड दस क्रिएट्स एन इमेज. इमेज एक मिल जाती है जो बिल्कुल ऑब्जेक्ट के जैसी हूबहू होती है. Reflective surfaces reflect almost all the light incident on it uniformly, right? There is not much variation in the angles of reflection between various points. Angles of reflection में बहुत ज्यादा फर्क नहीं होता है, ठीक है. एंगल ऑफ रिफ्लेक्शन हो गए. अगर हम इसमें एक परपेंडिकुलर ड्रा करेंगे, वी आर गोइंग टू स्टडी आगे लेक्चर में, बट यहाँ पे थोड़ा समझाने के लिए यहाँ पे हम एक परपेंडिकुलर ड्रा करेंगे. इट हैज टू बी स्ट्रेट. ये हमारा एंगल ऑफ इंसिडेंस है, तो ये हमारा एंगल ऑफ रिफ्लेक्शन है. ये दोनों एंगल सही नहीं बना, अदरवाइज ये दोनों एंगल्स जो होते हैं, दिस एंगल और दिस एंगल, ये दोनों एंगल्स सेम है, ठीक. Source of light is visible in such reflection and the reflecting surface is referred to as a mirror. इसमें क्या होता है, ये जो जिस जिस चीज से ये लाइट आ रही है और स्ट्राइक हो रही है मिरर पे, दैट विल बी सोर्स. सोर्स नेसेसरली वो चीज नहीं है जिससे जो लाइट खुद इमिट करे, नो. इट में इस पे स्ट्राइक हो सकती है लाइट, और वो लाइट इससे स्ट्राइक होकर के मिरर पे स्ट्राइक कर सकती है, तो इससे ये विजिबल बन जाता है. सोर्स बिकम्स विजिबल, राइट? सो हियर वी हैव टू मेक इट श्योर दैट वी अंडरस्टैंड सोर्स ऑफ लाइट. वो चीज जहां से लाइट उठ करके स्ट्राइक होती है मिरर पे. सोर्स ऑफ लाइट, आई रिट्रेट, इज नॉट ओनली द सब्सटेंस दैट प्रोड्यूसेस लाइट. इट मे बी अ सब्सटेंस जहां से लाइट रिफ्लेक्ट होकर के इस मिरर पे स्ट्राइक करती हैं, और ये फिर रेगुलर रिफ्लेक्शन से एक इमेज बनाती हैं जो कि बिल्कुल हूबहू वैसी होती है जैसा हमारा ऑब्जेक्ट है. एंड सच अ टाइप ऑफ रिफ्लेक्शन जहां पे बिल्कुल पॉलिश्ड सरफेस है, यूनिफॉर्मली सेट मॉलिक्यूल्स है, जो वेव फ्रंट एक ही डायरेक्शन में रिफ्लेक्ट हो रहा है, दिस विल बी आवर स्पेक्युलर रिफ्लेक्शन. Second, let me just show. यहाँ पे हमारे पास we have got water and we see clear, proper image of all the stuff. It is observed in water. Why? Here water behaves as a mirror. The light rays that strike this water, that are emitted from these mountains, from these trees, and strike the water, right? They are reflected uniformly and create this image. This is what is called a specular reflection. None of the things, इनमें से कोई चीज source of light नहीं है, but जो इन पे light पड़ती है, daylight, sunlight जो पड़ती है, that is reflected from these mountains and trees and strikes this water, and it is uniformly reflected in our eye, and we get this image. Another thing, we have got diffused or irregular reflection. This is the main difference. In case of regular reflection, we saw that we have got an optically plane mirror. The molecules are uniformly arranged. Here we saw the molecules are not uniformly arranged. We saw the molecules are in sort of zigzag fashion, right? Here, what is the consequence of this? The consequence is when a uniform wavefront strikes it, the reflected rays, they are in all sort of directions, right? They do not preserve the this signature pattern, जो इसका एक pattern है, characteristic pattern है. It is not observed, it is not preserved in the reflected rays, and what is the outcome? The outcome is we do not observe an image. We do not observe a clear image of the this substance. Either we may observe a fuzzy image, yeah, we may not observe an image at all. उस टाइम क्या होता है, जो हमारी रिफ्लेक्टेड रेज होती हैं, they give us information regarding the shape, regarding the characteristics of the reflecting surface, and thus this reflecting surface becomes visible, right? So in case of specular or regular reflection, the source becomes visible. In case of diffused or irregular reflection, what happens? The surface becomes visible because it doesn't preserve the signature pattern of the object. Rather, it gives us information about the surface and makes the surface visible. That is how we are able to see different objects that are not polished, that are sort of rough. They become visible because the reflected ray gives us information about their shape, color, and other things. Rough surfaces other than mirrors, where the molecules are not uniformly set, they give us diffused or irregular reflection. This may be due to the material or wear and tear in the surface. या तो material is rough, it won't be able to form an image. Yeah, we have got a material that would have formed an image had it been fresh, had it been polished, but due to the wear and tear, due to the scratches, we are not able to just find an image. We are not able to get an image. ये हम mirrors वगैरह में भी देखते हैं, जब वो worn out हो जाते हैं, scratches पड़ जाते हैं इनमें, तो we don't get a specular reflection, right? Rather हमें fuzzy images मिल जाती हैं. The rays incident at slightly different points on the surface. This is the incident wavefront on the surface, or reflected in completely different directions. See, they are reflected in completely different directions. And what happens by this reflected light? Although the image is not formed yet, it gives us an idea about the surface from which the reflection occurs. That makes it visible, as already explained. It gives us an idea about the surface, and thus it enables us to see the surface. So thus it enables us to see non-shiny surface or objects. Here you can see this is specular reflection, water, still water rather. See, here again water. But this is not still water. And what happens? The reflection is not regular. We get a fuzzy or hazy sort of image. This is irregular reflection. So for specular reflection, the surface has to be uniformly set. It has to be sort of completely uniform. And when there is a slight sort of disturbance, even a surface that would give specular reflection may give rise to diffuse reflection. Third reflection, we have got multiple reflection. What happens? What do we understand by multiple reflection? Multiple reflection is, for example, we have got a mirror, right? We have got an object, and obviously we will observe image of the object right here in the mirror. Take. Now, if we have got some another mirror, I'm sorry, one moment. So we have got another mirror. Let us say it somewhere here. This object, this image rather, will serve as an object for this mirror, meaning thereby the image of this object, although is an image, but for this mirror it is an object, we will get an image of this object in this mirror, right? If we set some other mirror like this, we will get the image of this in this mirror. So when one object produces so many these images, this is what we call as we call it as multiple reflection. This multiple reflection, we do observe it in our day-to-day life. I will be just explaining that. So a single image is formed when an object is placed in front of a mirror. Reflective surfaces such as mirrors are very good at preserving the intensity. यानी जब एक इस मिरर पे इसकी इमेज बन गई, राइट, एक ऑब्जेक्ट की इमेज जब बन गई मिरर पे, यहाँ पे जब मिरर पे बन गई इसकी इमेज, तो इसकी इंटेंसिटी प्रिजर्व हो गई, एंड दिस विल सर्व एज द सोर्स फॉर अनदर मिरर. This multiple reflection is possible until the intensity of the light becomes low to the point when we cannot see. ये मल्टीपल रिफ्लेक्शंस तब तक होती जाएंगी जब तक कि जो इंटेंसिटी ऑफ लाइट है, जो लाइट ये इमिट हो रही है, इसकी इंटेंसिटी बहुत कम हो जाती है. The number of images we see is dependent largely on the angle between the two mirrors. जो दो मिरर्स के बीच में एंगल है, इस पे डिपेंड करेगा नंबर ऑफ इमेजेस. We see that as we go on decreasing the angle between the mirrors, the number of images goes on increasing, and when the angle becomes zero, that is when the mirrors become parallel to each other, the number of images become infinite. So number of images can be found out, can be obtained by this formula, is equal to 360 degree divided by angle between mirrors minus 1. This is our multiple reflection. Yeah, this is what we observe in our day-to-day life. Here's a person sitting in front of a mirror. Here's the image. Barber holds a mirror in order to show this man the back of his head. For this mirror, this will serve as a source, right? And this person will see the image in the front mirror. This is an example that we observe in our day-to-day life. Again, this is multiple reflection. Now, what are the laws of reflection? So, I can say since childhood we say that angle of incidence is equal to the angle of reflection. That is our law. That is our first law of reflection. So, as already said, the incident ray strikes this surface. Basically, this is a wavefront that strikes a surface. एक wavefront surface को strike करता है, and this ray, it represents the direction of this wavefront. This is the incident ray. This is the reflected. This is the incident wavefront. This is the reflected wavefront, right? This ray, this reflected ray, is perpendicular to this reflected wavefront and represents its direction. Similarly, the normal, it is perpendicular to the surface and represents the direction of the surface. We can put the law, angle of incidence is equal to angle of reflection, in two ways. One is the angle between the incident ray and the normal, that is the angle of incidence, is equal to the angle between the reflected ray and the normal, right? This will be one way to put it. But as students of chemistry, I don't know आपने कभी ये इस चीज पे गौर किया होगा. Another thing is basically we can also put it like this. ये हमारा, अगर हम इसको इस वेव फ्रंट को ये करेंगे, इसी तरह से इसको भी करेंगे, ठीक है, हम इसको पूरा दिखाएंगे, ठीक है. तो this wave front strikes the surface and the angle between this wave front and the surface, this is also angle of incidence, right? इसी तरह से the angle between the, I need to draw it straight but I am not able to. Okay, this, okay, ये हमारा reflected wave front, the angle between the reflected wave front and the surface, reflecting surface, angle between the incident wave front and the surface, reflecting surface. Similarly, the angle between the reflected wave front and the reflecting surface, this is our angle of reflection. So our first law goes, our law of reflection goes, angle of incidence is equal to angle of reflection. Equally, the angle of incidence is equal to angle of reflection. ये भी angle of incidence ही है और ये भी angle of reflection ही है. This is our law of reflection. The angle of incidence is equal to angle of reflection. Angle of incidence may be considered as the angle between the incident ray and the normal. This is the incident ray. This is the normal. Angle of reflection may be considered as the angle between the reflected ray. This is our reflected ray and the normal. This is our normal. Okay? Likewise, angle of incidence may also be considered as the angle between the incident wave front and the surface, right? And this surface. Similarly, angle of reflection may be considered as the angle between the reflected wave front and the reflecting surface. So this is our, I hope it is clear. You can, this is not only way by which you can represent the angle of incidence. This is also the angle of incidence. Second law is the incident ray, the reflected ray, and the normal ray. They all lie in the same plane, right? Let me first show you that this is the, this is our, this has been clearly shown. This is our incident wavefront. This is the surface. This is also angle of incidence. This is the reflected wavefront, as I have shown it here. This is the reflected wavefront. This is the reflecting surface. This is the angle of reflection. So angle of incidence is equal to angle of reflection. What about these two angles? These two angles. Let us say, let us name them as angle 1 and angle 2. Angle 1 and angle 2. I say these two angles are equal. How? If you see this ray, it is normal to the surface. So this angle will be equal to 90 degree. So also this is normal. So this angle will be equal to 90 degree. So we may write angle 1 plus angle I is equal to 90 degree. Okay. Similarly, angle 2 plus angle R is equal to 90 degree again, right? From first and second, angle 1 plus angle I is equal to angle 2 plus angle R. But angle of incidence is equal to angle of reflection. So this and this goes. What we are left with? We are left with angle 1 is equal to angle 2. Hope it's clear. So this angle also, this angle 1 will be equal to, this angle 1 will be equal to angle 2. This is how it goes. So we may state the laws of these laws of reflection as the incident ray, the reflected ray, and the No, this is not refracted. I'm sorry. This is normal. This is normal, not the refracted ray. This is normal, right? The incident ray, the reflected ray, and the normal lie in the same plane. It states that the angle of reflection equals to the angle of incidence. Theta r is equal to theta I. Okay? The angles are measured related to the perpendicular. They are measured related to the perpendicular to the surface at the point where the ray strikes the surface. यानी कि related to the perpendicular किसके हिसाब से measure किए जाते हैं? Obviously मैंने आपको बोला they are measured with respect to the normal. जैसे ये हमारा ये है, ये इंसिडेंट रे है, तो इसको हम नॉर्मल के साथ मेजर करते हैं। ये हम इस से हम मेजर करते हैं। इसी तरह से इस रिफ्लेक्टेड रे को भी हम नॉर्मल के हिसाब से ही इसको हम मेजर करते हैं with respect to the normal. I hope it is clear, and in the next lecture we will be discussing refraction. Thank you so much.